Hello everyone, welcome to my channel Math Pandit Learning Hub. So as we discussed in the previous session, this time we are going to cover the second part of the course, Kinematics of Machine. So we will begin the course with velocity analysis and mechanisms using graphical vector approach. Let us first see the outline of the sessions that will be covering this topic. First we will talk about what is an absolute motion and what is a relative motion. Then we will discuss briefly about the basics of vector. Then we will discuss about the velocity analysis of a link. Afterwards, we will see the graphical vector procedure to compute the velocity analysis of different links in a 4-bar mechanism. Then again we will see the graphical vector procedure to compute the velocity of different links in a slider crank mechanism. So first we are going to start with the velocity analysis of basic mechanisms such as 4-bar mechanism and slider crank mechanism. In the end, we will take up some numerical problems dealing with certain complex mechanisms. So in these numerical problems, we will demonstrate the application of graphical vector procedure to compute the velocity of different points on different links in a particular mechanism. So let us start with what is an absolute and what is a relative motion. So let's talk first about absolute motion. So the motion which is defined relative to a fixed frame of reference is called an absolute motion. So let us try to understand this through an example. Let us consider a Cartesian coordinate system, something like this. So let us say this is my x-axis, this is my y-axis, this is my z-axis, and then O is the origin of this Cartesian coordinate system. Now let us define the motion of a person A with respect to the origin O of this Cartesian coordinate system. Now let's say this person A, it is walking in any particular direction, and the motion of this person A, it is being defined relative to this point O, which in turn is the origin of this Cartesian coordinate system xyz, and again this Cartesian coordinate system xyz in turn is fixed in nature. So in that case we can say that the motion of person A is absolute motion. So once again I am repeating that this is true only when this xyz coordinate system is fixed. Now let us see what is a relative motion. So as opposed to the absolute motion, a relative motion is a motion which is defined relative to a moving frame of reference. So let us further understand this through an example. So let us again consider a person B, right? Now as you can see here, the motion of this person B, it can again be defined with respect to this fixed coordinate system xyz, right? So you can say the motion of this person B with respect to the origin O of the xyz coordinate system is a absolute motion. However, let us now assume a local coordinate system attached to this person A. Now we can see here, if we establish a local coordinate system which is attached to this person A, and we know that this person A is moving in a particular direction. So here you can see this coordinate system x prime, y prime, z prime, it is moving in nature, right? So if we define the motion of this person B relative to this coordinate system x prime, y prime, z prime, then we can say the motion of B with respect to A is called as relative motion, right? Now you can see here the x prime, y prime, z prime coordinate system which is attached to person A, it is moving in nature. Now let's talk about certain basics of vector. So let us first see how can we represent a vector. So let's say we have been given a physical quantity denoted something like this, that is AB vector. Now what does this AB vector represents? So this AB vector, it simply represents a vector whose magnitude is equal to AB and the direction is from A towards B. Now since we are dealing with kinematics of mechanisms, so this AB vector, it can basically represent three physical quantities. So the first physical quantity is the position vector. So what is this position vector? It is simply denoted as RBA vector. Now let us try to understand this. What is this? So let's say again we have a Cartesian coordinate system, something like this, x, y, z with origin at O, and let us say if we have 2 points A and B in this Cartesian coordinate system, then RBA vector, it simply represents the position of point B relative to A. Similarly, VBA vector, it simply represents the velocity of point B relative to A. And in the same fashion, we have ABA vector, which represents the acceleration of point B relative to A. Now let us see how can we represent these vectors through a diagram. So a vector, it can be simply represented by a straight line with a arrowhead. Now this arrowhead, it will be put in a direction from A towards B. For example, if we have the vector RBA vector, which represents the position of point B relative to A, so the direction of RBA vector, it will be from A towards B. So the arrowhead, it will come at this small point B. Similarly, if you have velocity of point B relative to A, so you can see here again it can be represented with a vector AB. Now this AB vector direction is from A towards B. In the same fashion, you can also represent the acceleration of point B relative to A. So ABA vector, it will be again represented as AB vector with the direction pointing from A towards B, right? So you can see here that this point small a, it represents the tail of the vector, and this point small b, it represents the head of the vector. In the direction of a particular vector, it will be always from tail towards head. Now let's talk about the addition and subtraction of vectors. So let's say we have three vectors, VAO vector representing the velocity of point A relative to O, VBO vector velocity of point B relative to O, and then we have VA vector which is representing the velocity of point B relative to A. Now you can see here that VAO vector and VBO vector, they are simply representing the absolute velocities of point A and B relative to some origin O of a Cartesian coordinate system. VBA vector simply the velocity of point B relative to A. Now let us see how these three vectors, they are correlated with each other. Now you can see here, generally these three vectors, they are related by the equation VBO vector equal to VBA vector plus VAO vector. You can also write down this thing as OB vector is equal to OA vector plus AB vector. So you can see here that the addition of two vectors, that is VBA vector and VAO vector, it will simply give you VBO vector. Now, if you observe here, just to avoid any confusion, when you represent the velocity with something like this, that is VBO, then the letter V, it will come before the letter O. However, when you write this equation in this particular format, then you can observe here the letter O, it will come first and the letter B, it will come afterwards. So just remember that it is simply representing, this OB vector is simply representing the velocity of point B relative to O, in the direction of this vector is from O towards B. Now let us see how can this thing be represented through a vector diagram. So let's say we have OA vector in space, something like this. Then we have AB vector in space, something like this. Now, if you try to observe, right, what we have done here, we will simply superimpose the tail of this AB vector to the head of OA vector. So after superimposition, right, we will simply join this point O with B. Now you can see here these three vectors, that is OA vector, AB vector and OB vector, they are forming the sides of a triangle. So this law, this addition law, is generally referred to as triangle law of addition of vectors. Now here you can simply see that VBO vector is nothing. This VBO vector is simply the resultant of VBA vector and VAO vector. Also, if you observe this VBO vector or OB vector, it is forming the closing side of this triangle. So this OB vector, it is basically the closing vector. And now you can see here the direction of OB vector, it is opposite to the direction of VAO vector and VBA vector. So this is how the three vectors, they will be related to each other. So once again, just to summarize, we can say the absolute velocity of point B is equal to relative velocity of point B with respect to A plus the velocity of point A relative to origin, that is the absolute velocity of point A. Now let us see how can we apply the addition law when we have more than two vectors. So let's say we have several vectors lying in space, something like this. So you can see here OA vector and AB vector and BC vector and CD vector. Now obviously here if you observe this VDO vector, that is absolute velocity of point D, it is simply given by relative velocity of point D with respect to C plus relative velocity of point C with respect to B plus relative velocity of point B with respect to A plus absolute velocity of point A, that is the velocity of point A with respect to origin O. So the resultant vector in this case will be this vector, that is OD vector, VDO vector. In this resultant vector, it is the summation of four vectors. The first vector is OA vector, another vector is AB vector, another vector is BC vector, and another vector is TC vector. Now you have to simply remember that what you are doing here, you are simply superimposing the tail of one vector to the head of another vector to obtain the resultant vector OD. So let us try to understand this further. So you can see here what we have done. We have superimposed the tail of AB vector, that is this point A, to the head of OA vector. So A represents the tail of AB vector, but this point A, it also represents the head of OA vector. Similarly, here this point B, it represents the tail of BC vector, and again it represents the head of this AB vector. So this is how you keep on superimposing all the vectors, and then finally what happens when the last vector, that is the CD vector in this case, it ends at point D, then what you simply do, you simply join this O with D to obtain the resultant vector. So in a similar fashion, if you have n number of vectors, you can apply the polygon law of addition. Generally, this can be referred to as polygon law of addition to obtain the resultant vector. Now let's talk about the subtraction of two vectors. So the subtraction of two vectors is nothing. Let's say you have a vector A, B vector. Now what you do? If you reverse the direction of this vector, then it will simply become as minus BA vector. Right? So let's see what is actually meant by the subtraction of two vectors. So you can see earlier we had a relation, that is absolute velocity of point B, this is equal to relative velocity of point B with respect to A plus absolute velocity of point A. Now here this VBA vector is simply what, if you take this VBO vector and you subtract this VAO vector from this VBO vector, so you obtain the relative velocity vector, that is VBA vector. So you can again represent this thing through the triangle. So you can see here, this is basically your VAO vector, right? And then again this is VBA vector, and again finally this is your VBO vector. So you can trace the direction here, that is OA vector and AB vector. Their directions, they are in the same order. But if you consider OB vector, the direction of OB vector is opposite to the directions of these two vectors, that is OA vector and AB vector. So VBA vector is simply what? The subtraction of these two vectors, that is VBO vector minus VAO vector. Now, with this, we have simply discussed certain basics of vector. And again, just remember the triangle law of addition, or you can say the polygon law of addition. These things we are going to apply for calculating the velocity of different links in a mechanism. So with this, I would like to conclude this session and see you in the next session. Thank you.